vapors. So today we will discuss about processes of vapors naman. So kung maalala nyo kasi from our thermodynamics 1, siya nga pala yung activities na ipapas nyo sana no Monday. Ano na lang, ipas na lang sa
Activity,
Mondays.
sir? Anong activity
Yung
po?
take-home quiz, kailan yung hard copy na. Sige,
Exam natin, sir, next year.
next year na.
Next
Well,
year na.
wala pa tayong na-discuss gaano eh. Anyway, so going back, so sabi ko nga, from Thermo 1, di ba, meron tayong technically two pure substances. We have air, and then we have water, di ba? So both are used in power generation. Yeah. But then, Thermo na-discuss natin yung processes of or properties and processes of air, kung paano nag-move from point 1 to point 2, kung ano yung change ng properties niyan, or vice versa, 1 to 2. Kung anong change of properties from temperature, pressure, and volume. And then we also discussed thermodynamic cycle regarding air processes such as diesel cycle, Otto and Carnot, diba? Kung maalala niyo yung mga yan. For example, this is the Otto cycle. And so, this time naman, so sa Thermo 2, we're gonna talk, sabi ko nga din last meeting ata, we're gonna deal with vapor or bodies of water. Kung paano yung processes and changes niya. Mainly, tayo, liquid to gas or vapor. So, kung meron tayong properties and processes of air or gases, meron din tayong processes of vapor. Sige, let's start. So, i-discuss lang natin kagaya ng properties of gases or processes of gases. Okay. So, yung common message. So, yung hindi. Of course, hindi. CO2, hindi ko maalala. I-recon ko lang dito. Recall lang natin ulit. I-recall lang natin ito ng first meeting. Okay, CO2 is, or si Carno muna, ST. Or we have here TS diagram yan. And this is PV. Ayan, recall lang natin. So, Carno is ganyan. Isentropic or constant entropy. Tapos, isothermal and then isentropic isothermal. Yung PV ni Carno is looks like this. And curve yan, curve ulit, tsaka curve din dyan. Si Otto naman is SVSB or constant entropy, constant volume, constant entropy, constant volume. So, tsura ng TS niyan is ganyan. Then si PV naman ni Otto, so baliktaran lang nun. So, nakaganyan. Then diesel is SPSB. Yung PV niyan is ganito. So, tayo nag-i-start. So, 1. TS ni diesel looks like lang din TS ni Otto. Ayan. So, I hope na-recall nyo na, naalala nyo. So, okay. Once again, processes of vapors tayo. Meron na ba kayong steam table? Karamihan ba nakabili na? So I hope kayo,
On the way pa lang, sir.
obtain kayo ng steam table. So magagamit natin yun. Sige, okay. So yung ideal gas loss, wala, hindi na natin yun. Kakalimutan natin yun, di ba? Bukan natin sa Thermo 1. Yung PBMRT, ganyan. And then yung mga, ano pa yung iba doon? Mga gilusak, boils and chars law, wala, hindi natin magagamit yun sa Thermo 2. Mainly, ano lang yun, mainly cycles and processes involving air or gases lang sila, PBMRT. So, pang Thermo 1 lang yan. So, processes of vapors, let's start with, of course, isometric muna tayo. Isometric. Isometric meaning constant volume. So, umpisa natin yung diagram niyan. So, kung paano nag-iiba or paano gumagalaw yung properties natin. So, for diagrams ng PV and TS diagram ng vapors or water. For TS, meron tayo laging saturation curve, di ba kung maalala? Ito yung i-discuss natin yung sa thermal processes of steam. PV naman is ganyan lang. Medyo shallow or narrow pala na curve lang sa malapit sa PV. So isometric meaning constant volume lang yan. So let's say we have here point 1. Say dito. This is point 1. Of course, gagalaw lang yan. Pababa. Straight line pababa. So point 2 na yan. Yan lang yung parang movement yan sa PV diagram. So sa TS naman, let's say we have here the saturation curve. Very hindi distinct na line or very uncertain line yan. So let's say we have here a point 1. Ang galaw niyan pababa is swervy. So bakit swervy ang TS niyan or volume sa TS? Simply kasi we're talking here about vapors, diba? So technically, as it heats or either as it condenses, as it vaporizes or as it condenses, hindi uniform yung niya, hindi uniform yung change in state or volume niya, change in volume niya. Kung ma-imagine nyo, di ba, papainitin nyo yung vapor or steam, tubig sa hangin, yung mga particles or molecules niya, very violent or hindi mapakali or galaw-gaw. So, medyo magulo yung nasa TS niyan or curvy. Ganyan. So, formulas for isometric process. So, sa formulas lang medyo parehas. Pero the process is not the same kasi nga iba yung tinitreat natin from air or gas as naging liquid or vapor pala. Vapor or water dito. So, work non-flow, of course, ganun pa rin yan sa ating katulad sa air. That's just the integral of from 2 to 1 upper limit. This is still PDV or pressure multiplied by the change in volume. But since we're talking about isometric here, so technically, magiging 0 lang yan, but magiging 0 si dV. Simple kasi, let's say, V1 and V2 are equal. So parang magiging V1 minus V1 lang yung yan, equation yan. So, magiging 0. Yan. And then, any number naman or any pressure na i-multiply sa 0 is magiging 0. So, for workman flow ng isometric process natin for vapors is 0 lagi. Parang si isometric ng air or gases. Process of gases. Process of air. Next is work steady flow. Work steady flow is same lang din. So negative integral of v or v dp. Yeah. So simply, pag distribute natin si volume sa pressure, magiging ganyan lang yan. But since, since from our graph, ang ang movement ng pressure natin as it cool downs is bumababa. So, madalas mas mataas ang pressure 1 natin. So, pag minus natin si P2 sa P1 is magiging negative ang value ng P2 minus P1. Kaya if pwede nating i-rewrite to, kasi may negative pa rin dito. Ito, balik natin itong negative. Ito i-rewrite yung general formula for work and work steady flow as V then P1 minus P2. Ito yung parang general working formula natin. Also, we can also solve, lagay ko dito sa taas, we can also solve work steady flow for vapors to as summation or di pala summation kasi may minus. So, ito, formula is the heat minus the change in kinetic energy minus change in potential energy minus enthalpy. Yan. Steady flow. Next formula, we have internal energy. Change in internal energy. Change in internal energy, same lang din yan. Mass multiplied by, hindi na tayo mag-deal here with MCV delta T. So, in processes of vapors, normally, kasi since hindi nagba-vary or parang fixed na ang specific heat ng water sa 4.187 or 4.186, so on. Yan lang, mismo. I-rerekta na natin yung internal energy mismo. Yan. So, ang makukuha kasi natin sa team tables, yan. Pakita ko lang sa inyo kung ano yung tsura ng loob ng mga book natin. Yan. So, this is for superheated steam. Apart, bandang kwan yan. Last parts. Then, this is the saturated table or saturated temperature, saturated pressure part ng steam tables. Yes. So, normally, problems natin, given pressure and temperature as properties of vapors. And then, kunwari, meron tayo, sinabi sa problem na 80, alabas na temperature sa turbina or turbine is 80. Saturated temperature is 80. So, ito, titrace lang natin yan para right. So, given ang saturated temperature na 80, makukuha natin yung mga properties of vapor. So, let's say, for example, under this column, meron tayo dyang internal energy. So under 80 degree, makukuha natin yung UF, internal energy na saturated liquid. Yan. So maalala nyo, di ba? Ito yan. Meron tayong curve na ganyan. And then dito yung critical point natin. So saturated liquid, lahat ng tatama dito sa left part ng line, and then subcooled liquid ang region na to. Same time, dito is saturated vapor, then superheated itong region na to. And then under the area ng curve natin, this is the wet mixture part. And so ito din, kung baga i-maximize ko lang yung nakalagay sa taas, internal energy, enthalpy, and entropy. So meron ding tatlong column under or sub-column under these columns. So for example, dito sa enthalpy, merong HF, merong HFG, then merong HG. Yan. So ano yung kwan yan? Ibig sabihin yan. So under HF, ito yung enthalpies nung kwan, nung enthalpies at saturated temperature, let's say for example 80 nga. Yan. So enthalpy at 80, ito. So ano ito, no? Yan. So enthalpy na 80 at saturated liquid. Yan. So enthalpy ng 80 dito sa part na to. Meaning, subcooled liquid pa yan. Yan. So pag sinabing HF, kasama na rin dyan yung dito na part or subcooled region. So ang enthalpy at saturated liquid under the saturated temperature na 80 is 335.02. Yan. So next is HFG naman. Sa HFG, let's say for example, HFG, di ba? HFG meron tayong value na 2308 kilojoule per kilogram. So yan yung enthalpy natin na wet mixture yan. So technically this is 50-50 sa HFG. Meron kasi tayong what do you call this? Meron kasi tayong paano na-explain yan? Paano sabihin? Meron kasi tayong sinusolve or kunwari let's say, sinusolve kasi natin ang mixture ng kunwari enthalpy, di ba? Meron tayong M na lang to. Usually sinusolve natin ang enthalpy niyan at certain point. Kunwari dito, diba gitna yan. So, let's say dito nag-fall yung point natin. So, usually may given tayong moisture, quality of moisture. Tinatawag nating X. So, sabihin yan kung kasi 80% quality of the mixture. Ganyan. So, pag 80% sinabi, ibig sabihin 80% vapor, yung wet mixture natin is 80% vapor and then 20% na water. Kasi ba kung meron tayong pinakuluan dito, pinapakuluan tayong tubig dito and then nag-vaporize na yan. Kasi yung tubig is, ang volume niya is 100 liters yung tubig. So let's say for example, sabing meron tayong the vapor's quality is 80%, sabi niya ganyan. So yung vapor natin under this kasirola or boiler is 80% na steam or 80% na vapor, 20% na water or tubig pa. So meaning 80 liters yung volume ng steam or vapor na dito sa taas. Then 20 liters yung tubig. 20 liters na lang yung tubig na natitira. Okay, so how do we solve for, let's say, the wet mixture natin? So, mag-solve si wet mixture by Ito is enthalpy of mixture. Kasi, for example, given tayo ng at 80 degrees Celsius, meron daw tayong wet mixture na 60%. Ayan. So, paano i-solve yun? The wet mixture is solved as HF at that point, saturated, plus X HFG. Ayan. So, technically, ayan. So, 355, 335 pala, 0.02 plus, so that's 80%. Let's say 80% yung ating mixture. So, 0.8 nung itong 2308. Ayan. So, yan yung enthalpy nung 80% na wet mixture. So, ayan. Solve nyo na lang sa calculators nyo. Ayan. Given na meron tayong wet mixture. Ayan. Huwag ko muna kayong magbasa ng steam table. And then HG, syempre yan yung enthalpies natin at saturated vapor. So for 80 degrees Celsius na saturated temperature natin, ayan, nandito yung enthalpy niyan. So ang enthalpy niya, before maging superheated steam, nandito yan, diba? Saturated vapor is 2643.0 kilojoule per kilogram. Ito yung nakalagay naman dito kung ano yung units. Super entropy, ayan. Internal energy, and specific volume. Any questions ba, class? Before tayo bumalik sa processes of vapors. Ito muna pala bago yung vapors. Questions? So, pag nalito kayo, sabihin nyo lang, ulitin natin. Wala. Okay. So, punta tayo dun sa superheated steam na table. Ayan. So, dito naman, normally, back to the curve ulit. So, as as the vapor continuously heats up, ayan. So, mapupunta na yan sa superheated steam na region. So, ayan. Pag lumagpas pa yung natin, yung values of enthalpy natin, or pag umihit pa, beyond 80, and then tumaas yung pressure niyan, kahit 80 pa lang yan, magiging superheated steam na yan. Ayan. So, nakabukod to doon sa saturated temperature na steam table. So, under superheated steam tables, and nakikita nyo naman dyan. So, normally, saturated pressure yung isa-isang table or tabulated. So, for example, dito sa 100 kPa. Yan. So, this steam is saturated at 100 kPa. So, tuturuan ko kayo siguro sa Monday kung paano mag-interpolate. So, ewan ko kung may mga alam ng mag-interpolate sa inyo. Pero, turuan ko kayo sa Monday. So, interpolation meaning, kumari, given tayo ng pressure and then given tayo ng temperature, hahanapin natin yung value ng H or enthalpy at that point. Yeah. So, kung nga 100 kPa or 100 kPa pressure and then given tayo ng temperature na 220. So, kukunin natin yung value ng enthalpy at the yung gitna or dito sa part na to. Yan. I-discuss ko kung paano kunin yun sa Monday. So, syempre, around kwan yan, ano ba yung kwan? Gitna niyan, 75 times. So, around 2925 yan, or 29220, 2920 kilojoule per kilogram. And, anyway, ayun, superheated steam. Ano yan? Diretso yan. Basta habang umiinit yan, fixed pressure or saturated pressure, continuously tataas din yung properties of steam, enthalpy, entropy, and energy. Okay. So going back, ayun, doon natin nakukuha yung values ng internal energy sa steam tables natin. Next is our change in enthalpy. Ayan. Change in enthalpy is ganoon din lang naman, H2 minus H1. So by unit analysis, since kilojoule per kilogram ang enthalpy na nakukuha natin. Syempre usually, given naman dito na mass is in mass flow rate. Ayan. So, kilogram per second. Then, makukuha natin, or minsan, kilogram lang, para ang nakukuha nating enthalpy or internal energy or heat is under kilowatt or kilojoule. Siyempre, makakancel lang si kilogram sa mass and then yung kilogram na denominator ng enthalpy or internal energy natin. So mapapansin nyo, meron tayong capitalized N, small h. So babantayin nyo yan. So small h symbolizes specific enthalpy. So specific enthalpy meaning merong kilogram lagi sa baba. Ganon din si internal energy. So merong big U and then may small u. So ito, alisin na natin to para kunwari big U. So, technically, H is yan, kilojoule per kilogram ang unit niya. While big H, kilojoule only or kilowatt or kilojoule lang yung units niya. Wala na yung over kilogram or denominator na kilogram. Yan. Pati din sa ito, pag-U or walang puntot, kilojoule or kilowatt yung units niya. And then if small u, kilojoule per kilogram yung unit. Yeah. I hope that's clear. Next, under isometric process is the heat transfer. Parang sa parang sa air process of air pa rin. Heat transferred, that's simply delta U lang din. Gaya sa ating air. Simply kasi heat is ganun pa rin naman. Ganun pa rin siya nusol. Delta U plus work ng flow. But since wala tayong work ng flow, or zero ang work ng flow natin, kakancel lang yan. So heat is delta H. Or, ito, M multiplied by U2 plus U1. Then, lastly is our change in entropy. So, change in entropy naman, ayun, mawawala lang yung specific heat tsaka yung lon natin. So, rekta na rin to, mass. And since makukuha naman natin sa table, yung hindi na siya lon of temperatures, kukuha na natin yan sa tables, yung values ng entropy. Yan. So, since obtainable by tables, entropy, change in entropy is, yan lang din. Small letter S2, small letter S1, and then this is capital S. Any questions for isometric process? So, mag-raise lang ng hand or mag-type sa info messages if there are questions. Next is isobaric. Isa-isain lang din natin. Isobaric meaning pressure is constant dito sa process na to. So if we will draw the PV and TS diagram, sa mga late kanina, ayun. So sa PV and TS natin, we're dealing here with vapors na kasi. Hindi na siya simple air. Sa air natin is malinis yun. So 0.1 at 0.2 lang. So sa vapors natin, may kasama tayong curves. So kung maalala nyo, ito yung saturation curve ng vapor natin. Yung may critical point dito. That is for TS. And then for PV naman is payat yan. So mainly mas malapit sa pressure or Y coordinate or Y axis natin. Yan. Para si movement ni volume is ay sa to kanina. Si movement of volume is very hindi survey or parang hindi siya matukoy kung paano or paano siya nakiki-interact sa TS. While here in isobaric is um, fixed yan or parang may pattern yung movement ni pressure sa ating TS. Okay? Even TS. PV, yan. Then TS natin sa gitna. Parang bell yan. Okay, so obviously, under isobaric, ang movement lang ng from point 1 to point 2 is horizontal since si volume lang nag-vary. Say for example, this is your point 1 and then this is your point 2. Yan. So under TS naman, ang movement lagi ng pressure is yan. So habang subcooled yan or tubig pa yan, slope yan or slope. Parang diagonally. Or pwedeng ganyan. Pwede rin ganun. Basta may slope yan or diagonal going up, right up under the subcooled region. And then pagpasok naman ng pressure natin sa wet mixture, pag enter niya sa saturated liquid and then wet mixture is straight line lang yan. Straight line lang yan dyan. Sa straight line yan. And then pag exit niyan sa ating curve or once it exits from the saturated vapor is magda-diagonally ulit yan sa slope yan. Diagonally pataas ulit yan. So once it enters the wet mixture region, straight line. This is just isang pressure lang yan. Like say for example, 100 kPa yung vapor natin under isobaric process. 100 kPa lang yun. Yung buong yan. So ma-appreciate nyo yung dito na part once we go to the thermodynamic cycles regarding vapors. Okay. So, for isobaric, ganun lang din naman. So, work ng flow natin. That's just integral ng PDV. So, pressure, V2 minus V1. So, work steady flow naman natin, since this is the negative integral of VdP. And so, change in pressure natin, magiging zero lang yan, since, ayun nga, isobaric or constant pressure. So, work steady flow natin is just zero. Ano pa? Formulas natin is the change in internal energy. Triangle yan. Ayun. So, still, that's just U2 minus U1 or mass minus quantity U2 minus U1. And ayun lang din. Ulit-ulit lang. So, delta H naman or the change in enthalpy is mass times the change in specific enthalpy or H2 minus H1. E is our heat transfer. So, for isobaric, kung maalala nyo sa ating dun sa air, dun sa air processes natin, for isobaric, ang heat natin is mainly equal yan sa change in enthalpy. Ganun din dito. Ganun din dito. So, galing lang din yan doon sa ba't ganyan? So, meron kasi tayong formula before, di ba na? Ganyan. So, Thermo 1. For isobaric, heat is equivalent to the change in enthalpy. Next is our entropy. Entropy is ganun pa rin. Mass times the entropy 2 minus entropy 1. Ano pala? Screenshot nyo na lang yung important formulas or formulas natin for isometric mode.
Sir,
Hmm.
kanina pa ako nalulutang, sir. Ano mo ulit yung U?
U is internal energy.
Ayaw. Thank you, sir.
Okay. Ito yung sa isobaric. Paki-screenshot na lang po. Yeah, okay. So, para ma-appreciate nyo, let's try to solve for problems na lang regarding the processes for isometric mode. Wala ako. Okay, so 1 kilogram of steam. Ibaba natin yung temperature. Wala tayong saturated. Ito lang yung ating 260. Habang 260. 180 na lang. Please. Pwede. Okay. So 1 kilogram of steam at 180 degrees Celsius and with an enthalpy of 1861 kilojoule per kilogram is confined in a rigid container. Ayan. So heat is applied until the steam becomes saturated. Okay, so magiging saturated vapor yan. Or if draw natin muna yung TS natin. PV and TS na lang. Wait. So, ganyan yung curve natin dito sa PV and then TS is, yeah. So this is isometric. So technically yung pan yan, hindi importante yung PV nito kasi yan lang yan. So it's 0.1 and then 0.2. So kung naman natin, curve natin TS is ganyan. 0.1 to 0.2. So nireheat natin or hinit natin hanggang maging saturated steam yung saturated vapor yung ating 1 kilogram of steam. So from 0.1 to 0.2. Technically, andito lang yan sa part na yan or HG, kumbaga. So dito, 1 kilogram of steam at 180 degrees. And with an enthalpy of 1861 kilojoule per kilogram is confined in a rigid container. So heat is applied until the steam becomes saturated. Determine natin yung heat. Determine natin yung the change in enthalpy, change in entropy, tsaka T2 or final temperature. So kukunin mo natin yung properties of steam. This is 180 degrees Celsius saturated. The temperature saturated natin. Kukunin natin yung properties sa 180. Okay, ko na alam yun. Malapit. So under 180, meron tayong hindi nakasama si internal energy, no? Entropy at enthalpy lang. Okay, pero isometric to, so kung ano yung internal energy, yun yung heat natin. Okay. So under 180, meron tayong internal energy na ito, or UF natin is 761.92. Okay. U1 natin is equivalent to UF at TSAT or temperature saturated. TSAT natin is 180 degrees Celsius. So once again, ito yung UF natin, 761.92. That is equivalent to 761.92 kilojoule per kilogram. Okay. U2 natin. Oh, hindi, wait lang. So, okay, tama lang pala. UF muna to UF. Yung given kasi nating enthalpy is wet mixture. And so, paano natin nalaman na wet mixture yung enthalpy natin? Simple kasi dito. So, makikita nyo, in between siya ng 180. This is the enthalpy part. In between siya ng 763, which is our saturated liquid enthalpy, and then 277.2 na saturated vapor na saturated vapor under 180. So, doon muna tayo mag-i-start pala. So, kukunin natin yung enthalpy or ano tawag, yung moisture, quality of the moisture under the enthalpy. So, kunin muna natin yung enthalpy din muna. Which F natin is 763. Or HF at TSAT yan, 763.05 kilojoule per kilogram. And then, given tayo ng HFG at TSAT, that is 2014.2. Okay. Kilojoule per kilogram. So, pakilabas yung mga calculators, mag-solve tayo. So, kung maalala niyo yung formula na sinabi ko kanina, so the enthalpy of a mixture or a wet mixture is equivalent to the HF plus quality and then the HFG. Right. So, given tayo ng enthalpy, this 18, the temperature saturated at 1861. So, 1861 dito is equivalent to HF natin, that is 763.05 plus X. Solve natin X dito, multiplied by 204, 2014.2. Ma-cancel lang yung kilojoule per kilogram later on. So, kaya ko natin ilagay yung units. For this problem lang yung walang units. So, pwede yung i-shift solve, pwede ring mano-manuhin para mas mabilis. So, una is, tatranspose lang natin si 763.05 papunta sa kabila. So, 1861 minus 763.05. So, kung i-mental math natin, that is just 109 109 ilan to? 10 yan. Is equivalent to X 2014.2. Yan. So, masosolve natin yung X pag dinivide nyo yung 1097.95 all over 2014.2. So, ano yung wet mixture natin? Ano yung quality of our moisture? Hindi.
545.
0.545.
545, sir.
Okay, next is Ano yung ano, pag 4 decimal na?
Ano po sir, 1?
So, given tayo ng ano, what do you call this? Mm, moisture, quality of moisture, pwede nating masolve na yung H or the other properties. Then, if masolve natin the other property, o kumari, we get the H2 na ganun. Since meron tayong, or this is technically our H1 pala. Okay, so, okay, basta. We'll go back there later on. So, first we continue muna our processes. Tayo dito. So, for next process, si baka natin matapos. 10 minutes na lang is our isothermal. So, heads up lang pala. So, for P1, so most likely, since kinapos tayo sa meetings, um, face-to-face na test lang natin is would be our P1 exam. And then mainly ang CS natin is will be coming from the take-home quiz and then
Notes, aray.
ano,
Notes po.
notes. Yung notes kasi ano eh, tingnan natin kung madaming naghahabol kung P2 kasi syempre yung mag-umpisa yung pagdusa sa P2 since CS nyo dito is parang perfect kasi nga take-home or mataas ang CS nyo dito. Yung notes, maybe P2 or P3 lang yung notes if may hirapan. Gano'n.
Sir, kailan po ulit exam?
Exam natin is next year na lang yun. So most likely, it will be January 8.
Okay, sir.
Okay. So,
Sir, may gusto pa.
quiz 2 natin, malamang take-home quiz 2 na lang din para mataas CS niya. Pondo na nga rin yung CS niyo. Okay, next is isothermal process. So, sa Monday, discussion pa rin tayo. So, siguro solve tayo ng problems regarding processes. Maganda face-to-face natin i-solve. And then, kung matapos natin ng maaga, punta na tayong cycles. Isothermal processes, ganun. Same lang din to sa air din. Parang yung doon lang din sa isometric and isobaric. Sa isothermal, work non-flow natin. Ang gulo nung pagkakalistas ko ang problem. Mas babalikan natin yun sa Monday. Work non-flow natin. Hindi na siya valid. For isothermal, hindi na siya yung P1 V1 minus P2 V2. Ganun. Ang work non-flow natin is simply makukuha natin pag nakuha natin yung delta U. Work non-flow is saan galing to? Galing lang din sa formulang Q is equivalent to delta U plus work non-flow. So, tinranspose lang natin si delta U sa kabila. So, work steady flow naman. Work steady flow is kung paano natin kinuha yung work steady flow sa isometric. Steady flow is equivalent to U minus change in kinetic minus the change in potential minus the change in enthalpy. Next is our change in internal energy. So unlike sa air, processes of air natin, kasi doon we're dealing with temperatures. And then this is isothermal. Isothermal is constant temperature. And so for, di ba kung maalala nyo sa isothermal under air processes is zero, delta U and delta H. So dito, syempre meron pa rin kasi tayong enthalpies at that certain temperature. So may ma-obtain pa rin naman tayong value. And mainly, M U2 minus U1 pa rin. Then D, nag-change kasi yan ng state. Guys, na uniform yung temperature natin if the pressure is nag-iba. Yan. Tataas or bababa pa rin yung ating properties such as enthalpies and internal energy. So next is our change in enthalpy. So still mass times the enthalpy 2 as enthalpy 1. Letter E is our heat transferred. And heat transferred is yan. Pwede natin makuha sa ito Q if makuha natin kaagad yung work ng flow or given si work ng flow, pwede yung Q is equivalent to delta U plus work ng flow. But if hindi, kailangan natin kunin yan as temperature times dj, change in entropy. Yan, parang ganyan. Then lastly, our entropy. Ganun pa rin. Mass times V, entropy 2 minus entropy 1. Okay. Lastly, our isentropic or adiabatic process. Isentropic, since hindi na to air, so wala na yung K minus 1, kontura na exponents. Ganun. Kasi hindi na to air, so wala na yung specific heat ratio na tinatawag natin. Anyway, entropic process, this is constant entropy. S is equivalent to C. Okay. So nakalimutan natin i-drawing para sa isothermal yung ating PV and TS. Okay. PV and TS natin is just simply yan. Unahin natin yung TS. Ayan. So syempre, simply movement lang yan. Movement lang yan horizontally since fixed yung ating temperature. So let's say this is R.1, it's R.2. Yun lang. Then PV naman natin. For PV and change in temperature, may movement in. So from our right side or superheated region. Ayan. So let's say this is our point 2. Ayan. May curved slope yan, pataas. Puntang wet mixture. Ayan. Then once it enters the ito yung ating saturated vapor, mag-i-straight line yan. Parang kabaliktaran ni pressure. I-straight line lang yan under the wet mixture and then pag ano na yan. This is for isothermal process na PV. This is 1 to 2. So kung maaalala nyo yung sa isobaric, pag pressure na under TS is straight or line na may slope. Then once it enters the wet mixture, straight line. Okay. Reverse lang siya ni temperature under the PV diagram. So next is the isentropic process. So na natin yung PV and TS niyan. Yes. Okay. For our TS, gano'n lang din yan. Parang si temperature sa isothermal. So, ang movement lang yan is horizontal, vertical naman to since fix yung S natin. So, isang straight line lang yan. Let's say, this is point 1 and then point 2. Yan lang. So, for PV naman, ang movement na entropy when it comes to our PV, even this is our saturated curve, is ano, parang sa TS lang din, pero curve line, hindi siya straight. Ayan, so parang gumanon lang yan. Nag-curve lang ba? Just like the TS. Formulas naman. For work ng flow under isentropic, this is just simply delta delta U. Negative delta U. Saan galing si negative delta U? For isentropic kasi, diba? Sabi natin, isentropic is delta constant entropy. So technically we're saying na there is no heat na nalulus, wala ding heat na pumapasok, or this is an isolated process or insulated process. Walang heat na nagpe-penetrate, wala ding heat na nare-reject. So skip na tayo sa letter E. Therefore, our heat is 0. Yan. Diba? Parang sa air, kung lang din naman, isentropic sa air processes, heat is 0. So, kaya natin nakuha yung work done flow na negative delta U lang kasi wala tayong heat. So, galing lang din yan sa Q is equivalent to delta U plus work done flow. Okay. So, but since this is 0, transpose lang natin si delta U. Kaya naging negative delta U. Yun yung value ng ating work done flow. So, letter B, our work steady flow. Work steady flow is same pa rin naman, although wala tayong heat. Diba? Kagaya dito. Work steady flow is so on. But since heat is 0, so rekta na tayo. Change in internal, or change in kinetic energy minus the change in potential energy minus change in enthalpy. Okay. Next is our delta U. Okay. So bukod sa delta U natin is equivalent to negative work done flow. Ayan. And it is still our general formula for delta U. U2 minus U1. Ayan. Or Ayun nga, delta U could be negative work flow kung given kaagad sa work flow. The letter D naman natin is our change in enthalpy. So, general formula pa rin yun. So, mass multiplied by the specific enthalpy 2 minus specific enthalpy 1. And then ito, si E natin, yung heat transfer. And then last is our change in entropy. Of course, change in entropy natin is 0. Since entropy is constant. Entropy 1 minus entropy 2 will be equivalent to 0. So, meron pa tayong isang process. So, hindi siya yung polytropic. Since polytropic is simply gawing N yung K. Our next process is the isenthalpic or constant enthalpy. An isenthalpic process. Or constant enthalpy. Isenthalpic process is also called throttling process or throttling process. Let's start by doing the PV. Last na to. So for isenthalpic, so let's say this is our point 1. Wait, make sure. Movement is and curve line lang palabas papuntang superheated. 1 to 2. For TS naman, for TS, let's say we have our normal curve here, our saturation curve. Isenthalpic, isenthalpic, ang movement niyan sa TS is ganun lang left. So from this point, nag-move lang siya into superheated from 1 to 2. Yes. Formulas for isenthalpic. Work one flow. Or steady flow na lang kaagad. So work steady flow is 0. Delta U natin is still the same. That's mu2 minus u1. Of course, our ancient enthalpy is 0 since this is isenthalpic or constant enthalpy. Heat transferred din natin will be equivalent to 0 for enthalpic. And then E, our change in entropy is still the same. That is M S2 minus S1. So, ayun lang muna for now. Questions, please raise your hand and ask them now.
Sir,
Okay.
yung steam table ba, sir, pwede namin siya buksan sa exam, ganun?
Oo. Ayun. Ayun. So, steam tables, you can bring steam tables on tests. Pero kung once na may nahuli akong nag-cheat, so, most likely is magpapa-xerox na lang kayo kung ano yung gagamitin natin yung parts ng steam table. So, ayun, pwede nyo gamitin. So, huwag lang kayong magsisingit ng huli ko doon. Huwag lang kayong maglalagay ng mga formula.
Sige, sir.
Okay. So, attendance muna tayo before mag-dismiss. Mr. Asio.
Present po, sir.
Ayun, Mr. Jupiter. Ayan. Bukirin. Wala. Carpio.
Present, sir.
Castillo.
Present, sir.
Colombino. Wala. De Luna. Ay, okay. De Luna. Okay. Ferrer.
Present, sir.
Garcia.
Present, sir.
Lazaro.
Present po.